The new visualization features in MetNet Maker version 1.5 rely on Cytoscape, so it's worth just checking that that works. I've tested everything with version 2.7, which is the newest version of Cytoscape. There's no reason why the feature shouldn't work with recent versions as well, but I haven't tested them, so it might be safest just to use version 2.7 or later versions. So let's just have a little look at what these visualization features can do and how they can help us to see the networks that we're building. So the first thing we need to do is load up a network. So I'll just load up the example that we have from previous versions of MetNet Maker and also the Wikipedia example. And here's the top of glycolysis, the simple network that we built in a previous video. So we can see this is all loaded in. We could export this as SBML, but if we click on the Visualize in Cytoscape button, we've got a chance to visualize the network. So the first thing we need to do is define the path to Cytoscape. I've already defined it here, but if you didn't have it already defined, what you need to do is find the cytoscape.bat file. Here it is on this computer, and you just need to make sure that that links to the correct cytoscape.bat file. The next thing to do is choose the currency metabolites for the network. These are metabolites that you don't want to see large nodes for, and are compounds that you don't really want to track through the network. It basically means that in Cytoscape you can have multiple occurrences of each of these compounds and they appear much smaller, so you don't get distracted by them. So in this case I'm going to choose ADP and ATP and then just press send to Cytoscape. So now MetNet Maker creates the network in Cytoscape and loads that up for you. And it applies a custom style so that you can see that the compounds are here in white circles, the reactions are in red rectangles, and the currency metabolites are small and out of the way. We can see everything a bit clearer if we click on one of these layout options. I like the Y files organic option, and then we see that we have a network that's very much like what we want. So it might be worth at this point getting things looking how we want them, and you can use the built-in tools in Cytoscape to align nodes and lay them out as you'd like. So let me just quickly do that to try and get something that's looking a lot better. And it's probably worth taking 2 or 3 minutes at this stage to lay everything out quite well, because that'll help you in future to have a really good looking and easy to understand network. So you see, if we use all of the built-in tools in Cytoscape, this can actually be quite a quick process, and quite soon we end up with a very professional looking network layout that's telling us exactly what our network's doing. There we go. So now we've got our network laid out in Cytoscape, we might want to save this so we can open it up and look at it again later. I'm just going to save it in the MetNet Maker folder. This is top of glycolysis, and that'll save it as a Cytoscape session. So if I close Cytoscape and hide away MetNet Maker, then I can see I have this top of glycolysis session, which I can load up again. and this gets us back to exactly where we were before we saved it. There we go. The next thing that I'm going to show you is how we can merge visual networks. It's easy to merge networks in MetNetMaker. You just load both networks up and it merges them together for you. But merging visual networks is not something you can do by default in Cytoscape. And the key to merging visual networks is to use the XGMML file format. And so I'm just going to export this network as an XGMML file. So we can just save that as top of glycolysis. And there it is saved. So to show you about the network merge functionality that we have in MetNetMaker version 1.5, let me bring in some other files. So here we have a glycolysis and TCA cycle as Cytoscape session CYS files and their equivalents as XGMML files. So let me just load up the glycolysis example here. And you can see that we've got a detailed depiction of glycolysis all the way from glucose at the top down to pyruvate and lactate at the bottom. And we can also load up the TCA cycle session. And I'm sorry for the slow speed of Cytoscape. Unfortunately, it doesn't seem to be very compatible with the screen capture software that I'm using, but it still works. Normally it's much quicker than this. So there we go, there's the TCA cycle that I've laid out myself, similarly to the top of glycolysis example that I showed. And now what I want to do is merge this TCA cycle with the glucose pathway, glycolysis pathway that I've got here. And that's not something that Cytoscape lets you do natively. So let's just quit these two in Cytoscape. And you'll see that I here have the XGMML equivalents of those two that I've just exported using Cytoscape to XGMML. And now I can use the Merge XGMML Visualizations button to merge those two XGMML files. So here we have the Cytoscape path defined from before. We load up our first XGMML file, our second XGMML file, and I should just say at this point that this merging system will only work if the XGMML files were created from networks created in MetNetMaker. So the tool isn't general to any XGMML file, it is specific to network created using MetNetMaker. So we just click the Merge Networks button, choose a name for our merge network. I'll go for glycolysis and TCA, press save, and MetNetMaker will take care of merging those two networks visually for you. And displaying them as a combined single network with the properties of the currency metabolites for each individual separate network, but also any overlapping reactions connected together. So here it is. You can see that we have good connections between the networks. Sometimes if you want to see the names for everything all at once, you might need to change some of the settings and preferences in Cytoscape so that it displays a higher level of detail. But I think you can see here how we could build up, using this tool, a collection of all of the pathways for any given